Assalamualaikum warahmatullahi wabarakatuh. So we are from AS12026. Would like to present about one of the application of differentiation, which is maximum and minimum problems. So first of all, I would like to thanks Madam SYADATUL for giving us this opportunity to present to this topic. So first thing first, I would like to introduce my group members, which are Atira binti Muhammad Hasli, Nikno Aisyah binti Muhammad Syafaruddin, Siti Haja binti Zulkarnain, Nur Kamalia binti Rosli, and Tengku Khairinisa binti Tengku Nazmi, which is me. So, what is differentiation? So, differentiations in mathematics is a process of finding derivative or rate of change of a function. Introduction to maximum and minimum problems. Many application problems in calculus involve functions for which you want to find maximum or minimum values. The restrictions stated or implied for such functions will determine the domain from which you must work. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value.
Next, we will take a look at our objective. Our first objective is to create the equation relating to the unknown quantities from the problem given. We need to create the equation because it is necessary and it made it easier to solve this problem. Second, find the maximum or minimum value using derivative. We use derivative because the derivative provides information about the gradient or slope of the graph of a function we can use to locate points on a graph where the gradient is 0. Lastly, determine the maximum or minimum value by using the first or second derivative test. Now, we look into our problem statement. A piece of wire of length 240 cm is bent into the shape as shown in diagram. Question A. Express y in terms of x. B. Show that the area A centimeter square enclosed by the wire is given by A equal to 1880x minus 540x squared. C. Find the value of x and y for which A is maximum, and D. Find the maximum area.
For problem statement A, which express y in terms of x, to solve this problem statement, we need to know in the problem statement, it states that a piece of wire of length 240 cm is used. That means the parameter for the whole shape, which is shown in the diagram, is 240 cm. From this, we can make an equation from the shape parameter, which is 13x plus 13x plus 24x plus 2y is equal to 240 cm. Then we calculate all the x and brought it to the right side. Then we simplify the equation and get the answer, which is y equal to 120 minus 25x. Next, for problem statement B, it states that the area of the diagram is 2880x minus 540x squared. From the diagram, we can see there are two shapes, which are a triangle and a rectangle. So we create an area formula for the diagram, which is area of triangle plus area of rectangle. From this formula, we get 1 over 2 times 24x, the base of triangle, times 5x, which is the height of triangle, plus with 24x, the length of rectangle, times by y, which is the height of rectangle. Next, simplify the equation of the diagram area. We get 24xy plus 6cx squared. Then, we substitute the equation of y that we got from the problem statement A before into the latest equation and simplify them together, which is 24x times with 120, we get 2880x, and then 24x times with negative 25x, we get negative 6000x squared and replace with 60x squared. Then again simplify the equation and we get the area of the diagram is 2880x minus with 540x squared. From this, it is shown that the area of the diagram is the same as the area that stated in the problem statements.
My name is Siti Hajar and I will continue for question C and D. For question C, we have to find value of x and y for which A is maximum. We have two steps here. For the first step, we already know that A is equal to 2880x minus 540x squared. We have to differentiate for the first time and make it equal to 0 to find value of x. 2880x is actually x power of 1. We have to bring the power 2 in front and minus the power by 1. That's why after we differentiate, we will get 2880. Negative 540x squared. 540 is a constant, so we just copy it. X squared, we have to bring the power 2 in front and minus the power by 1. That's why after we differentiate, we will get 2x. 2x, we have to multiply it with 540. So, after we multiply it, we will get 1080x. We have to simplify the equation, and we will get x value, which is equal to 8 per 3. Next, y is equal to 120 minus 25x. We have to substitute x value in y equation. After we substitute, we get y value is equal to 160 per 3. The second step is we have to show A is maximum. How to show is by doing second derivative. First derivative, we got 2880 minus 1080x. After second derivative, which is d squared a per dx squared, 2880 will be 0. It is because it is a constant. Negative 1080x, x is actually power of 1. We will bring the power 2 in front and minus the power by 1. That's why we got negative 1080, which is the value is less than 0. When the value is less than 0, it shows that A is maximum value. We move on to question D. Find maximum value. We already know that x is equal to 8 per 3. And A equation is equal to 2880x minus 540x squared. We have to substitute x value into A equation. And after we substitute and simplify the equation, we got A maximum is equal to 3840 centimeter square. Why centimeter square? It is because it is area.
At the end of this video, we can make some conclusion. So the first one, can create the equation relating the unknown quantities by expressing y in terms of x, which is y equal to 120 minus 25x. Second one, we can conclude that the x value is determined by using first derivative and y value is determined by substituting x value into y equal to 120 minus 25x. So the third one, A is maximum shown by using second derivative and maximum error is determined by substituting value of x into the equation. A equal to 2880x minus 540x squared. So the last one, we can conclude the application of maximum and minimum are widely used in a real life. So the process of finding maximum or minimum values is called optimization. So we are trying to do the things like maximize the profit in company or minimize the cost or find the least amount of material to make a particular object.
This is the list of references that we use in making this presentation.
That's all from us. Thank you.